Hi, everyone. Thanks so much for joining us. My name is Karen Biza, and I'm on the developer relations team here at Databricks. And I just have a few slides to share with you as we kick off this meetup. Thank you so much for joining us. I'm really enjoying looking at the chat right now and seeing where you all are calling in from. It's always so exciting to see, the global audience. I was just taking some notes on different countries that I saw some folks in Dubai, Brazil, some folks in the US, in Colorado and Seattle, also South Africa and Bangkok. So exciting. And lots of folks from Europe. So thanks so much for joining us. So just a few quick intro slides. I'm going to share my screen here. All right, so we are here at the Databricks University Alliance meetup. This is the first meetup of 3 actually that we have this year at Summit. And I just wanted to do a quick call out to our meetup group. So this is where we promote a lot of our online content. We have a lot of great sessions that we run, usually on a weekly basis. And of course, especially when we have our summits, we run a few extra sessions like this University Alliance meetup. So I encourage everyone to check out our group and join us there if you're interested in kind of continuing along and seeing the content and different speakers that we have for you. So join us there on meetup.com. And then just a quick call out for our next 2 meetups that we have coming up this week. So on Wednesday, we have a meetup, Apache Spark 3.0 internals and building structured streaming microservice architecture. So that's coming up tomorrow, and you should be able to see both of these in your agenda in the platform. So you can check out more details there. And then on Thursday, we have kind of a MLflow, Delta Lake, and Lakehouse use cases kind of themed meetup for you. And both of these are going to be hosted by my colleagues, Denny and Jules. They're both developer advocates at Databricks. I think a lot of people know them. They're amazing. And they'll be joining me as well for those 2 meetups. And then one other thing I wanted to kind of share with everyone that I encourage you to check out is in the conference platform, there is a space. If you're on your left, the left nav bar, there's a Dev Hub and Expo, and that's where you're going to see kind of all of our sponsors and check out different things you have there. But one really cool feature is called Hallway Chatter, and these are all a bunch of kind of topical based chat rooms. And then within these different chat rooms, we actually have a few community lightning talk sessions that we're running this year that we're testing out. So check in there. I believe there's going to be one on Delta Lake, MLflow, I think Spark as well. So you just have to go into the chat rooms and check out the spaces. It's a great way to engage with other attendees and check out a few live sessions that we have coming up this week. So with that, I just want to do a quick one last housekeeping thing before I pass it over to Rob. Is the session is recorded, and so if you have to jump off early, they'll be available after the conference, and I believe the platform itself is going to be up for quite a few days after this week. So you'll get the recording, you'll get the access to all the materials that we cover today. So just wanted to call that out, that it's recorded, so you'll be able to view it at a later time if you'd like to. So with that, I'll stop talking and pass it off to the folks that you really want to hear from. And so I'd like to start with Rob Reed. He's also on the developer relations team here at Databricks. He's the University Alliance Program Manager who put together this panel. So with that, I'll pass it along to Rob.
All right, thank you, Karen. And thank you, speakers, for volunteering to talk about how and why you teach data science, data engineering, and data analysis at scale. We have 3 panel speakers today. Each of them will give approximately a 10-minute overview of their approach to teaching the next generation of students who are learning how to solve the world's toughest problems with data. After each panelist has spoken, We will have a moderated Q&A panel, excuse me, a moderated panel session followed by audience Q&A. Your moderators today are, in addition to Karen, who introduced the session so gracefully, you've got myself and Srijith Rajamohan. And Srijith is also a member of the developer relations team here at Databricks, and he has a PhD from the University of Tennessee in computational engineering. And prior to Databricks, and I'm smiling because I made a mistake and had the wrong university earlier. Prior to Databricks, he worked as a computational scientist at Virginia Tech. So Srijith and I will be working the Q&A and chat. Just a quick note that the event will end exactly at 7 p.m. GMT. And if we are unable to answer your question, or if you're telling us the world's most interesting thing, it may cut you off in mid-sentence. So it will end at exactly 7 p.m. And if we don't get to your question, then we apologize. With that, I would like to turn the microphone over to Kyle Hamilton. Again, it's a metaphor in these COVID times. And Kyle teaches a master's level data science course for Berkeley. That's from California, from her home in Ireland. So Kyle, I will turn it over to you. Thank you.
Thank you, Rob. My pleasure to be here. My name is Kyle Hamilton, and I teach at University of California, Berkeley, remotely from Ireland. So let me just share my screen here. Okay, and so I teach a course called Machine Learning at Scale, and it is what it sounds like. So we teach machine learning algorithms for big data, or at least data too big to fit on your computer. A little bit of background about me. So I am this two-headed beast with art on the one hand and science and math on the other. And I was putting this together. The last time I updated this CV was a couple of years ago, and I thought, oh, I better update this. And 2020 came along, and I thought, well, that's appropriate. Not a whole lot of work I have to do there. So I started out as a fine artist back in the 90s, went to Cooper Union, lived in New York for a while, and I did some graphic design and fine art on a freelance basis. That led to doing kind of web design. And then the web design led to doing web coding, and coding led to doing some actual programming and engineering. And then I ended up going back to school for computer science. I did computer science. I was a software engineer at a startup. And that, again, wasn't enough to satiate my curiosity. And I got my master's in information and data science in Berkeley. I graduated in 2017. And then I kind of fell like a heavy brick into a swamp, into teaching, when my professor of machine learning at scale asked me if I could TA for his course. And I ended up taking over that course essentially, and eventually kind of redeveloping the curriculum and developing course materials and the whole kind of structure. So now I'm pursuing a PhD because, you know, it's never enough. And I'm doing that here in Ireland, doing mostly graph neural networks and things like that. So the MIDS program at UC Berkeley is a professional master's program. It's taught entirely online. It always has been. It's made up of small classrooms, so 12 to 15 students, weekly sessions on Zoom. We have some pre-recorded asynchronous materials and homeworks and group projects. It's an advanced course that's usually taken towards the end of the program when most people have met all of the fundamental courses and requirements. Our students come from a very diverse set of academic and professional backgrounds. So for example, I came from fine art. We have PhDs in mathematics, we have financial analysts, we have neurosurgeons, we have journalists, and so it's a very diverse set of people, and as a result, a very diverse set of needs in terms of what we teach and how we teach it to cater to these very different backgrounds. So we're not all software engineers, so we have to make sure that our courses are structured accordingly. The focus of the course is machine learning. It's specifically implementing core machine learning algorithms. And to do that, students should have some prerequisite skills. So they've taken the fundamental courses, Python, Bash, linear algebra, applied machine learning. So they would have done sort of scikit-learn and small data sets, and then an introduction to statistics. So we cover the core machine learning algorithms. So we talk about optimization, regression, gradient descent in particular. We do a bit on graphs, PageRank, shortest paths, recommender systems, alternating least squares, and of course, decision trees, random forests, gradient boosted trees, and then gradient descent in function space. We do all of this in the MapReduce framework, and we introduce the sort of MapReduce design patterns with the algorithms. So word counting being sort of the hello world of MapReduce, right? The class is not a frameworks class, it's not a tools class, but of course we have to use certain tools in order to fulfill the learning objectives. So we start out designing a MapReduce framework using simply Bash and Python. So this is like the first exercise, the first foray that students have into MapReduce. Very quickly then we move to Hadoop streaming. Everything is done in Python because most of the program is done in Python. So we don't actually use Scala or Java or any sort of object-oriented languages like that. Once people have a comfort level with MapReduce and the paradigm and the concepts, we move to Spark. And we start out with working with Spark RDDs, the low-level API. And this is for pedagogical purposes mainly. Again, the emphasis being on understanding how an algorithm is actually distributed, right, in a MapReduce paradigm. And then we have a final project, which takes the last 3 weeks, six weeks of the class. The course is 14 weeks, so it's almost a half of the class. And we allow the students to use Spark data frames and Spark ML, having sort of learned the inner workings first. So the course is a lot to cover, especially for people who don't come from engineering backgrounds or not necessarily from STEM backgrounds even. So there's a lot going on. We have MapReduce, we have algorithms and data science, we have math and statistics, and then software engineering, data engineering, and infrastructure. So that's a lot for somebody coming from a background that doesn't cover any of these things. So we use Databricks for our infrastructure to take at least part of the sort of difficulty out of the machine learning ecosystem. And this has worked really well for us. So the holy grail in here is somebody in the center of that lovely Venn diagram. And then our final project, we then have a little website where I post slides from people's final project presentations. And these can be really fun to look at, and students spend a lot of time, they put in a lot of effort into engineering this large data set and running trying out different algorithms. And it's something that they can take with them, to an interview as a sort of finished product, an example of what they've done. So with that, I'd like to thank you for your time, and I'm going to pass it on now to Linus Wallen from Jönköping University in Sweden. Thank you.
Thank you so much, Kyle. So I'm just going to steal your screen share. Okay. So, hi everyone. So I will be talking a little bit about teaching with Databricks at Jönköping University. And I will start with introducing me. So my name is Linus Wallen. I've had about 10 years of experience as a software developer. I've been working with everything from search engine optimization, front-end development, DevOps, cloud architecture, and also now finally as a data engineer in my later days. So it's I'm kind of a person that once I've dug down into something, I kind of swap to the next thing, so I kind of understand everything around me. It's something that I really like. But today I am a squad lead and a data engineer at Husqvarna. And for those of you that don't know the company Husqvarna, it's a manufacturing company that manufactures equipment for forestry, construction, and gardens. But on my spare time, I help out at the local university, Jönköping University, in teaching students data engineering, because that's my field of expertise. And a quick note on why I wanted to do this. So I kind of just want to quickly touch upon when I first looked into big data, when I first got my hands on Apache Spark and tried it out. And for me, it was kind of suddenly realizing that you've had a toolbox and you've had this hammer for bringing down walls, but suddenly you got this sledgehammer to bring down walls. And it's like, wow, this is such an interesting tool. And I really wanted to share that with other students and other people, because it's such an amazing tool to have in your toolbox. So that was one of the things that spurred me on into teaching at Jönköping University. But why did I teach with Databricks then? Well, I thought about it a little bit, and I think there's two reasons why I teach with Databricks. So the first is that it was very easy to get started with working with big data problems right from the get-go. Getting the students to actually getting started with actual big data problems quickly. Secondly, I actually really wanted to show the students the tool that we use on a daily basis at Husqvarna for meeting business goals or creating value. So I really wanted to show them something real. And so what are my observations from using Databricks, and what are the things that I've kind of seen when I've been using it? And to kind of understand that, I will talk a little bit about my latest lab that I held. So my latest lab was, there was 85 students with very different backgrounds. One half was UX designers, another half was more towards software development and AI engineering. And so they had quite a different background. And what I did was I created a lab which was more focused upon what I know better, which is data engineering. So I gave them crappy data that they needed to clean. And after they've cleaned it, they needed to do basic analytics on it and kind of understand the data. And what I did, because the people have different backgrounds, especially if you look at my informatic to the right here, is that the students had to make a decision. Either I could do the lab in easy mode or in hard mode. In easy mode, you got more help, and in hard mode, you got basically no help. And the idea behind this is that the students that had a hard time, the one with the background that was more UX design, they would get more support, while the people that were thirsty for a harder challenge, they could choose that path instead. And then I set up also in AVS. How I set up was that I set up Databricks in AVS, and how the students validated their assignment, their lab, was that they actually used an API that I set up, and all those how should I say, attempts were stored down into S3, which is a storage container within AVS. And then I could actually do some big data on that to show the students with dashboards how they were doing and stuff like that, which was pretty fun. But what did I then find useful here when setting this lab up this way and trying to work with this task? Well, first of all, I found cluster configs and pools very useful. What I did was that I set up single node clusters so each student could create their own single node cluster, and to work on their specific notebook, on their specific problem. And then I made sure that the students couldn't create more clusters than the pool said, and I could really manage cost in a good way this way. Then I really also liked the Databricks API when working with this, mainly because it was a lot easier to create user accounts and assign everybody to a group. If you have 85 students, was a lot easier when you had a good Skim API to work against. And thirdly, I really liked working with secrets within Databricks, so I could hide API keys within the notebooks for calling this external API. And finally, I found it very easy to work with feedback, to be able to add comments, to be able to go into the notebooks and actually help the students along. That's actually, and the students really like that also, to be able to get this more hands-on help, especially when you can't meet up at the local university because of this current COVID situation. So that, I would say, are my observation, and that's all, folks. So now I will hand over to Oliver.
Great, thank you, Linus. Just a couple of minutes to share the screen. Am I sharing the screen, Rob? Could you confirm, please, if you see my screen? Should?
We don't see it yet, Olivier.
I need to start again. This is the screen.
There we go. It's coming up now.
Okay, perfect. Well, ladies and gentlemen, good morning, good afternoon, good evening, wherever you are. I'm really delighted to be with you today as part of this session, and thank you very much for having me. I'm going to discuss many different topics related to the introduction. You will get access to this presentation slides, so you will have an idea about what I performed, what I did in the past. Today, I'm acting as head of artificial intelligence programs within a French school called MBA ESG Business School. And at the same time, I'm acting as project director at Oracle Business Services, responsible for the implementation and integration of communication networks. For this presentation, this is what I offer, what I suggest as an agenda very quickly. I may not go through all these topics and may not give details about the syllabus. If you wish to have some details, I can go through that in the Q&A session. Well, first of all, just a couple of words about the organization to which I belong, MBA ESG Business School and Galileo Global Education. What are our offerings in the field of data science and artificial intelligence education? Why we teach data science and artificial intelligence at scale. I'm going to provide details about why and how, and our approach to developing learning content, as well as the teaching and managing virtual classrooms. Well, first of all, a couple of words about Galileo Global Education, which is a private company founded in 2011. And our mission, we have an ambitious mission today to be the world education leader in innovation, creativity, arts, culture, management, and technology as well. And what we are looking for, what all our schools, the schools of Galileo Global Education are looking for, is the professional development of our students, as well as their realization. Our programs are accredited and recognized by the relevant public authorities in each of the countries where we are, where we have presence today. Now, here are some facts and figures about Galileo Global Education. More than 100,000 student enrollments per year. We have more than 40 schools worldwide, 85 campuses, and in 13 countries. Within these 13 countries, more than 15,000 international students. Now, about MBA ESG, where I am heading artificial intelligence programs, MBA ESG is a Galileo Global Education Business School. We are offering today 21 MBA in different fields of innovation, creativity, arts, culture, management, and technology. We have a strategy, education strategy that is focused on case study as well as project management. And today we have 1,200 students who joined the Paris campus in September this year, and we'll have 300 students more joining the campus in January next year. Now, this is the architecture of our offerings in data science and artificial intelligence. We have a 2-year MBA program, first year dedicated to big data and artificial intelligence, and second year dedicated to artificial intelligence with the title Chief Intelligence Officer. Well, this is the evolution of the Chief Information Officer, because we think that information systems, when embedding, for example, a layer of intelligence, will become intelligence systems. So we are preparing our students for this future and emerging role, which is the Chief Intelligence Officer, where information systems are becoming intelligence systems. And this is, by the way, one of the programs in which we are working and developing with Databricks in order to get this concept of intelligence systems implemented and based on the data science platform. In the second semester, we offer 2 specializations in data science, a major in marketing and sales, as well as a major in supply chain and production. Now, why we teach data science and artificial intelligence? Because we are really in a very fantastic period where artificial intelligence is triggering a shift from programming paradigm to a learning paradigm. So we're moving from programming to learning. And this is one of the reasons why we introduced this new program within our school. And it's another way that there is a shift from production to intelligent production. We are moving from marketing to intelligent marketing. We are moving from a given topic to an intelligent topic. Why? Because we are looking for ways to embed intelligent solutions, machine learning, for example, deep learning solutions within the existing, with the legacy architecture in order to prepare for taking up the future challenges. And this is why we are really focusing on the implementation of data science and artificial intelligence programs within our. Now, this is a view coming, a survey coming from McKinsey, showing the impact of analytics and artificial intelligence introduction in many different fields of the industry, specifically services. And as you can see, we have really very high impact on marketing and sales and supply chain and production. something that you can easily understand, because since more than 30 years, we have been robotizing all our factories. And today, the idea, since we are changing a paradigm, is to move to the learning machine, or machine learning even, and by that, embedding a layer of intelligence in all legacy systems. You imagine how huge the business is behind this process of introduction of a layer of intelligence in the different in the industrial systems that we have today, specifically the legacy systems. And the idea of companies isn't really to purchase or procure or buy new systems. They would like to go from the existing architecture, from the legacy architecture, in order to get to a target architecture that embeds artificial intelligence. Big data, we can today say about data and artificial intelligence are here to stay. You can see the landscape 2020 today. These companies that are engaged and even involved in digital transformation, and specifically the wave of digital transformation that we call the artificial intelligence wave, which is going to be reinforced shortly by the quantum computing wave, where we are really expecting it. Now, how do we teach data science and artificial intelligence at scale? At the center of our educational strategy and methodology, we have the concept of hackathons. Why do we have that? Because even if we ask our students to work on case studies, or even business case study, this is not about business. It's not really business. You are preparing students to work in the business environment. They will be working on case studies, but we need to move further and even to reinforce these case studies by real case situations. And the real case situation is offered by hackathons, where you apply project management methodologies in artificial intelligence, for example, or in data science. These concepts are really important in order to get our students prepared for the future mission and to handle and to take up the different challenges raised by artificial intelligence, data science platforms that are going to be increasingly embedded in systems, and more specifically in intelligence systems. Now, our approach to developing and learning the content comes from the group's strategy, Galileo Global Education Strategy, to be committed to delivering excellent employability to its students, to our students. This is our target. We are meeting the enterprise, the company requirements by developing these programs. So this is our commitment, conditions for success of our future students. And the process that we follow is that we listen, we take into account the enterprise expectations and needs, and this helps develop the job market. We are identifying the current opportunities, emerging opportunities, to develop skills, business processes, skills, tools, and techniques. And it's only at the end that we define the business school curriculum, programs, and syllabus. So you see, as our strategy, our way of defining or developing the content isn't really based on, let's say, mathematics, physics, machine learning, deep learning. We know that this is required, but the most important thing in developing a business program is to listen to business. And listening to business, this is identifying expectations and needs, looking at the job market, and as a function of what the job market requirements, we define business process skills, tools, and techniques. And it's completely at the end that we select in our catalogs the syllabus, curriculums, programs that meet these, that help develop business skills, tools, and techniques as well. Now, our approach to teaching and managing virtual classrooms, and as you know, we are living really very specific, very special times today. This is one of the challenges that we need to take up all together in order to find solutions, get out of this crisis as quickly as possible. But being in the crisis, we need to manage the situation, and managing the situation for the meantime, we are using a tool called Blackboard Collaborate, Blackboard Learn, and our students are using this tool to learn remotely and to keep going, keep the momentum going, keep the educational momentum going, keep the learning momentum going. This is our purpose. This is our target, to help our students reach their objectives and accomplish their missions in the best way as soon as possible, waiting for the crisis to take end. It's going to be again very soon. I hope that I have been in the 10 minutes that I have been awarded. Thank you very much for listening. And I will be pleased to take part in the discussion session that now is going to take place now and to answer all of your questions. Thank you very much for listening and for.
Thank you, Olivier. That was important to me as something to talk about in this context of why we are teaching data science at scale. Ultimately, the students that are in the classrooms will be looking for jobs, and the availability of those jobs will be driven by industry demand, which is how do I use data and AI to solve a business problem that I have identified. So thank you for connecting those dots from value to the business, to things we'd like to teach in the curriculum, to actual large-scale analytics skills. So, and I apologize to the audience. Some of the audio from Olivier did cut out, but if you have specific questions, you can post them in the Q&A. With that, I think I'll turn this question over to the panelists, and we are dealing with a change in how we educate that was forced upon us by COVID. But think ahead in 5 years and think about what teaching might look like then. And I will talk more slowly to give Kyle warning that I will ask her this question first, and then maybe over to Linus, and then maybe again over to Olivier. So Kyle, just tell us what you think, and audience members, if you have your own input, either put them in the chat or the Q&A.
Sure, thank you, Rob. Yeah, so interestingly, from my perspective, I've always been teaching online because the program has always been remote. So we've been doing this for a good 7 years at least in Berkeley. Now I've been teaching for the last 3 to 4 years in the program, so I'm quite used to it. It's almost the only way I know because I wasn't a teacher before then. Hopefully in the future, the tooling gets better. You know, it works. I know it's really hard for people who haven't been teaching and learning online. I have a daughter who's 18 and she started college online this year, and it was really, really hard for her. So it takes an adjustment, but I think people can adjust and they will adjust. And I hope that the tooling gets better. Hopefully, you know, things like writing on a blackboard will be easier to simulate. You know, that's where I see it going.
Hey, sorry to jump in real quickly. Olivier, do you mind if you can stop sharing your screen? That'd be awesome, so we can see the folks better.
This is what I try to do. In fact, I stopped sharing it. So maybe better now, right?
Great. All right, thanks. Sorry to jump in.
Linus, go ahead.
So teaching in 5 years' time, if we need to go more online, for example. Yeah, well, I do like the idea what Kyle was talking about. I think that's, I mean, just having the visual feedback, but not having the smell, not having the touch, not having, like, those things are a limitation for working online. I mean, it would be great if we could, if VR could or augmented reality could be more introduced. That would be very interesting to see, at least as from a teaching perspective. That would be very, very. Then you could really expand and really kind of come up with some very interesting ways to actually kind of visualize and the teaching. That's what I would like to see more, and a cheaper kind of headset, so you can actually get a good experience easier. I think that's something that I personally would like to try out more.
And Olivier, I think it would be great to hear your perspective on what teaching will look like in 5 years. You're already thinking about the future, and in your particular organization, will there be in person? Will there be a mix? How do you see that working for ESG?
Thank you. As you know, we are preparing for the future. This is our mission, in fact, because our students will be taking part in this, the different challenges. They will be taking up these challenges. So we need to think today in the future, even if it's really difficult. When you look to the situation, to the current situation, it's really difficult to foresee the future within 6 months or 1 year. But we can at least have an idea about how can this future will be. I think someone said once, great transformations are really consecutive, are following crisis. And I think the COVID crisis that we are going through right now will have a huge impact on the way we are teaching. There will be no one solution fit all, you see, one solution that we can develop for all situations. I think distance learning is adapted to specific situations. Presence learning is adapted to other situations. And for specific, for example, in specific fields, you need to find a kind of balance or a blend between these two kinds of learning. So this is going to be discussed on case by case basis. But what I can see as a development, mainly two fields of development: the way in which we teach and what we will be using as a collaboration platform to get this teaching done perfectly. The way in which we teach, as I mentioned, there should be a mix, a blend, and I think distance learning is one of the must that's going to be developed in the future, within 5 years, for example. And the other thing is that we will have increasingly intelligence systems. You see, Rob, I'm really, I care a lot about this concept of intelligence systems, because we will be developing them. The PC or the Mac that you have today isn't going to be the same as the one that we'll be having in 5 years, because we will be embedding, in fact, layers of intelligence in order to get, let's say, collaboration platforms where people will be able to perform distance learning studies and even develop different ways of understanding and moving forward in the innovation, for example. I don't know if I covered the question that you asked.
Yeah, I'd like to upvote the collaboration, the tooling for collaboration when you're online, when you're in a virtual classroom, could benefit from some evolution. When you're in person, I suppose you can sit next to somebody, and if you're coding together, it's much easier than if you're sharing a screen and you have to write some code and one person is sort of trying to dictate and the other person is trying to interpret what they're trying to dictate, and they're learning how to code, the two of them. And it's quite, it can be frustrating and time consuming. So I think those tools, when they get better as well.
I do agree with you. I do agree with you, Kyle. And I would like to mention a technology that's going to be increasingly used in the future, which is mixed reality technology.
Sure. Yeah. And like
we should be able now to, we should be able now to kind of manipulate or use these virtual objects. And this is something that we are going to use, and it's going to be, let's say, developed if you are able to embed these data science platforms in this technology. So we will be integrating or implementing or embedding intelligence systems, layers of intelligence in mixed reality, for example, and get it a reality much more. Because as you know, science fiction today is becoming science fact. You can see that. So virtual reality or augmented reality, as well as mixed reality, will bring, let's say, augmentation to this artificial intelligence, which will become augmented intelligence. And these are one of the tools that we'll be using within, let's say, a couple of years extensively to go further in the collaboration.
Yeah. But now I have a question as more from a data engineer point of view, which is dirty data. when you get crappy data and you have to do magic on it, how do you teach that to the students? That you like, how do you introduce? Okay, like you don't get the perfect data sets and then do the magic. It's kind of usually you get, here's something really bad, and here you have something else that is kind of bad, and I need to do something with this. So how do you teach with that? That's something I'm very curious about.
I can answer this question
yeah.
by giving you an idea, because you know, for data or data preparation, this is today 80% of your time.
Yep.
When you move to modeling and when you move to developments, for example, to conclusions, this is very quickly. So the time that you spend is in exploring data, it's in preparing data. Yep. And how we do this? Well, there are different ways, innovations that are undergoing, in progress, to get this dirty, let's say, data much more clean. Well, you need to act at the source level. Because, from where did you get data, for example? If you, for example, act at the data when it is delivered, well, it's going to be a little bit difficult, in fact, to manage it, and you need to give examples and to move step by step forward. But if you are able to act at the source level, you can get clean data, and instead of working on a sandbox or a data lake, just work on streams. And before bringing data to the data lake, if we are able to clean the data at the stream level, we will have a better, maybe, data lake in better conditions to swim within, right?
Absolutely.
Yeah, I think part of the issue is just the expense. If when you're dealing with lots of data that can't be processed on your laptop, you know, in my class, for example, the students get 2 large data sets for the project, and they have to join these 2 data sets. And there isn't a single join key, right? So they have to figure out how to make that work. And the data is sort of clean-ish, but it's not perfect. So they have to figure out how to do it efficiently, you know, and how not to make mistakes. So I think what would be beneficial would be more efficient tools to process data sets. So as Spark gets better and better and better, these things can be done quicker and quicker and quicker. So yeah,
there is a solution. There is a solution for that, and it's interesting what Linus has described in his presentation. You know, the solution is to go to the cloud, because we know. Even if today there's a discussion to know if you need to process data locally or move to the cloud, since we are experiencing a huge amount of data coming from the Internet of Things, because the Internet of Things will be releasing or developing or delivering huge amount of data, and we need to know where to process this data. Are going to process this data locally, or we need to cloud? One of the solutions that we have today is, because these solutions are available, and these are one of the solutions that Linus described in his presentation, is to move to the cloud and to make processing within the cloud. You can use these data science platforms within the cloud, and in SaaS mode, software as a service, you can develop applications in the cloud, waiting for new environments where you can process data locally. And I think there will be discussion in the future. Today we are discussing the future of teaching. Is it going to be distance learning or presence learning? And the discussion that is going to be developed as well at the same time, are we going to perform local processing or even cloud in the cloud processing? And I think the solution is going to be in between. In 80% of the situations, it's going to be in between, in fact. And you know, it's very difficult to use. Yeah, sure.
And I like the in-between, yeah, because currently if we do everything in the cloud, it's not very cost effective, right? So that's, I'd be curious to know what the in-between solution is.
Yeah.
Well,
one thing I want to bring up is the divide between data science and data engineering also in teaching that, because that is, for me, at least from my own working space, is that so you tend to see that certain people like to do more data engineering, and other people tend to like to do data science a bit more. And sometimes you get these rare people that like both. And I have not met that many, but like usually you kind of go to one or the other. But here we need to teach, at least I understand, like it's good to teach the students both, so they can kind of choose themselves, where do I want to proceed my career afterwards? Because from my point of view, the data engineering perspective is like, we need a lot of data engineers, and there's not that many that really knows how to work with big data today, as at least from my own perspective.
Indeed, I do agree with you. This is, by the way, the experience that we are offering to our students in the first year. In the first year, we ask them to make a choice. We just all solutions, so that to help them making choice later, you know. The choice is going as more in the order in which you have these roles. Because if you look to the value chain of data analytics, in fact, the data engineer is the role that's going to be developing data preparing data for the data scientist, because the data scientist role comes after the data engineer. And the data scientist role is much more multidisciplinary. This is why you have a strong connection with artificial intelligence, because to make data science today, you need for sure to have knowledge in mathematics and statistics and in computer science, but mainly in business. And the data scientist without a business card or without a business knowledge is lacking something. The data engineer doesn't need to go through the business matter or business issues, because this is the role of the data scientists. And both roles will be collaborating, working together in this value chain to deliver value to the customer, in fact. And this is the final purpose of the whole process, because if you are implementing, for example, data science programs or data science processes, it's because you are looking for value to get from data. And the value that we'll be getting from data will be feeding artificial intelligence systems. And in their turn, artificial intelligence systems will be delivering more data that you are going to use in order to feed the data science process value, etc. So it is really very interesting times in which we are today. All these technologies are under development. We don't see today solutions to these different questions. And this is why I see the future as bright. The future is bright because we will be developing really fantastic solutions, introducing new systems that will help us get a better life, I think.
I think Srijit has a question, but he might be on mute.
Yeah, I just realized that. I had a couple of questions that can be addressed by any of you guys. So, there were two questions. I think the first one, most of you are actually talking about right now, in the sense that what level of data engineering skills does a data scientist need to have? You know, we're sort of maturing in the field of data science, and we're getting to the point where people are talking about this full stack data scientist, where you're talking about data engineering, cleaning the data, modeling, then you have to visualize the data. So you're asking for a person to do all of the above. But at some point, we have to say a data scientist needs to have a bare minimum set of data engineering skills before he can be productive. So maybe, you know, any one of you guys can shed some light on what would be necessary to be productive in a business setting or an academic setting.
So I think it really depends on where you go to work, because if you're going to work in a small startup, you're going to have to wear all the hats.
Right.
If you're going to work for Google, you probably only need to wear one small hat. So when we're preparing people, I think we need to give them at least an understanding of the ecosystem, and they can choose the path that they want to follow. But you can't expect, you know, everybody to learn everything. And that's kind of what I've learned from teaching my course, which started out as this massive course where we were trying to teach absolutely everything from Bash to cloud to the machine learning algorithms and the statistics and the math and the programming and everything else. We were expecting the students to learn from scratch and implement from scratch. But I think hopefully with, you know, better tools also being developed for the data engineering side of things. And even the machine learning algorithms that are being developed by frameworks like Spark and TensorFlow and Keras and all those other frameworks, they're gonna get easier to use. There's the phrase democratization of data science comes to mind, right? So yeah, so it depends, to answer your original question, it depends where you're going to work.
I may.
Olivier.
Yeah, thank you, Serge. I do agree with you, Kai. I do agree with you. This depends. This is something that we experienced as well. This was as well our conclusion when setting up POCs, which is the proof of concept, developing these, let's say, new programs, the MBA programs. I share with you the idea that it depends on the company in which you are working. And in this company, sometimes you will be specialist, full stack engineer, full stack developer. And in some companies, you are a front-end developer, back-end developer, data scientist, data engineer. This depends on the context in which you will be operating. You can cover the full value-added chain, or you can cover just part of this value-added chain. Now, what I would like to complete, I agree with you on this question. What I would like to say, Serge, is that we today, as you know, data science platforms are we are accelerating the development of these platforms. And what I can see, but maybe this is a little bit premature, you know, the data science platform is going to become exactly as a calculator. Because today when you are processing an operation, for example, processing the root square of a given number, you don't go through the analytics and calculus that is required to get this root square. You just take your calculator and you push some buttons and you get the result immediately. And in the data science platform, I think we are moving to the meta development. So even today, programming is required in R. Kyle talked about Python. I think it's important to share as well Scala, Java, C++, C#. These programming languages are still important, but we are moving to a situation, to a scale where these languages are embedded in all of our systems, and we are managing meta systems, you see, exactly as we use the calculator today. We will be using one day data science platforms exactly as we use the calculator. The calculator can be used by anyone without specific knowledge in analytics, in vector space or anything else. And data science is going to be used exactly the same way as we use the calculator. You just push a button and you get the result. The issue that to which we need to find a solution or an answer is what Linus raised with regard to this dirty data, because this is something that we don't have in a calculator and we need to deal with when developing data science platforms.
In that case, I'm going to go into something that another thing that I've been pushing for a long time now within my own company, which is data mesh, if you've heard about the concept, where you actually give ownership closer, like the people that generate the data, as you talked about, Olivier, that you give them ownership of building data sets. And that is because a lot of time, what I've seen at least, is that you send away data and you're like, yeah, it's going to land somewhere and someone's going to do something. But then you don't really care about your data. You don't really care about, but you're the domain knowledge. You know this data, but because you're sending it away and don't take responsibility for it, there can never be any really value creation. And that is something that I recently learned, that this is something that's very important to address. Yeah.
Exactly. And I'm going to push forward this idea that you just introduced, which is really quite interesting, because it's a question of architecture, in fact. When you are doing integration, you are managing suppliers. So when you are doing, managing data lakes, you need to manage data suppliers they will be providers. So you can fix, or you can, determine a couple of conditions, requirements that you're asking them to meet. They will be meeting these requirements as suppliers, and you as data engineer working on this data and making integration of data will get data that meets your requirements. So I think there should be kind of architecture to be introduced at this level, and to develop what we already developed and what we master today as techniques, with this notion of integration, or the integrator, the data supplier as a service provider, delivering data following your requirements to get this to simplify the process of getting dirty data clean.
Yeah.
If you are a generator of data, you should consider the data as your children, and make sure that when they go out into the world, they're well behaved.
Exactly. If you work in a squad or in a team where you actually, you manage your APIs and you manage your events, why shouldn't you manage your data also? I think it's simple as that.
So the researcher in me kind of wants to ask this question to all three of you guys and say, maybe slightly controversial, but do you foresee any challenges in to use Olivier's analogy of a calculator without the understanding of vector calculus, of potentially abusing models without understanding maybe some of the assumptions that go with those models? So do you think we're getting to a point where people can all just push a button, you get answers, but maybe not a qualitative level of understanding of the assumptions? I see Olivier raising his hand.
Yes, exactly, because in fact, this is the challenging aspect of the question, Serge. In fact, the challenging aspect is that we need to set up and the data processes exactly what we implemented 40 or 50 years ago in quality management. I think there should be kind of quality processes to apply to data. We need to imagine how quality can be, let's say, configured or adapted to data processing. Because look, if we are able today to use a calculator, this is because the technologies required to develop the calculators were subject or to different quality processes, huge and drastic quality processes. So if we are able to imagine these quality processes in the situation of data analytics, for example, we will be able one day to get this data science platforms available to anyone without specific knowledge in analytics or in mathematics or in computer science. So it's a question of quality and processes for quality. And am I thinking about the actions of the ASQ, the American Society for Quality? They are developing ideas and perspectives about this. And I think they should be encouraged to move forward in these developments, and even quickly, because we need this data quality processes applied to data science.
Yeah, I like that answer. I think you're referring to sorts of checks and balances in terms of governance of the solutions that come from these models.
It's W. Edwards Deming is smiling right now, Olivier.
Yeah,
that made me.
It should be.
Yeah, that's a great mention. Quality.
Now the follow-up question, that was my second question that I had for you guys, was we talked about moving to the cloud. So there are, so I was at an academic institution before, and we had folks who would hesitate to move their data to the cloud for various reasons. Their funding model doesn't allow them to do so, or there are various restrictions from agencies that would not allow you to move data to the cloud. So how do you deal with that situation?
You could have a mixed setup. It depends upon what you can move up to.
On-prem model.
Yeah, I was thinking about hybrid cloud. You have some things on-prem, and then you can have, if it's storage, for example, and you don't have enough storage on-prem and you want to keep that in blob storage, if it's Azure or S3 buckets, if it's AVS, you can do it that way. And then you do the compute down, because that's cheaper probably if you have on-prem. That's one way, I guess.
Yeah, I think Kyle mentioned the point of cost. So I think keeping partly on-prem and sort of bursting to the cloud seems to be the strategy that a lot of universities are adopting now. So
there's something important, Sridhar, when you move to the cloud, is the data protection regulations that we, for example, today in Europe, we have this general data protection regulation that to the cloud, data should be in the country where you are developing this data. And the issue is when you are a multinational company with many different data centers, for example, to be used. If you would like to set up an architecture to manage the data coming from these different countries while being in line with the data protection regulation, this is an issue that we need to solve. We have ideas about the way in which we can take up this challenge, even if these ideas are still doesn't have the mature level that we are expecting them to be. So, but data regulation is very important when you move to the cloud, and there should be a solution between being in the cloud and on-premise solutions, because moving to the cloud offers you the opportunity to set up MPP, which is the massive parallel processing, and this is something that you cannot do on-premise. If you are, as Kyle mentioned, for example, if you are dealing with huge data sets, massive parallel processing in the cloud is a must. When you are dealing with small data sets, maybe a solution on-premise can be let's say, developed. But there should be a balance between these two situations. And the data scientist, by the way, as well as the data engineer, should know how to get this balanced, exactly as the project manager today is able to balance cost, time, and scope. Well, data scientists and data engineers should be able to balance on-premise and cloud and the management of this data in PVC. So this should be something balancing.
It should be said also that we do only cloud actually, and the reason for it is it's simpler sometimes actually. Yeah, it's also
simpler,
kind of
faster.
simpler and faster, sometimes easier.
So to bring this back to teaching, right?
Yes, yeah, good.
We're kind of expanding the scope of the conversation, and we can't teach everything, right? So I think we have to refocus, right? What is this course going to teach? What is this course going to teach? Is that, GDPR, does that really belong in a machine learning course? Well, yes, maybe on some small level, maybe we have a discussion about it, but it's not, I don't think it should be the focus of the concerns, so to speak, or even, storing data in the cloud. If we're teaching algorithms, then do we also have to teach data storage? I feel like we're trying to boil the ocean, right, in our teaching.
I think you need both. You need, because when you define what is the data center, in fact, when you move to the cloud, you are doing storage, you are doing processing, in fact, and you need to know the network interface in order to get data to the cloud, for example. But with regard to the teaching question, in fact, go back to the scope, to the initial scope of this session, even if we always go beyond the scope when we are talking about technology, is that teaching our students, in fact, we need to teach them how to learn and how to forget as well at the same time very quickly, because technology is evolving at a very fast scale. And what they already learned, in fact, it doesn't apply anymore. So they need to learn more. So we need to give them the opportunity to learn how to learn, in fact. And by doing this by themselves, because even continuous learning and the development, if you long life learning, if you wish, this is a must as well, and we need to teach them how to do that. So what they will be attending courses, for example, at the school, and these courses will help them take up the challenges in the year or the 2 years that follow their graduation. But in years after, they need to learn by themselves the new technologies, long life learning.
That is a question that kind of I want to bring up here to you guys is, I mean, let's take just Databricks as an example here. It's a very good, I think it's a good tool for teaching, but it's, I mean, for one, like it's as you were in, Oliver, like forgetting something and learning something new. Like there is a mentality sometimes that let's throw as many new things as we can, so that students can learn, when they're outside of the university. And but one thing I was thinking about, if you use one tool during a whole semester, you can tie a very nice red line and actually build upon the things from the first course and do the next thing and really get this, okay, I understand it. Like if I want to learn ETLing first and I get crappy data in, okay, I built my goal data sets now, and now I can start building the actual models, and I'm going to do the ML flow pipeline to get the whole. So there's a downside is that you might not be able to deliver the whole picture if you don't stick to one thing sometimes. But then again, then you don't get the learning part, as you said, forgetting learning. So that was something I see
the point that you are raising, Linus, in fact, and you make me think about this French thinker, Gaston Bachelard, who once said in one of his books, the education of the training of the scientific mind, he was saying that every new knowledge shouldn't be added to the existing knowledge that you have, but should be an opportunity to reconsider the whole knowledge that you already have. So for sure, you are learning new knowledge, in fact, but this should be the opportunity for you to re-examine, to discuss, to reconsider what you already learned. When I said, for example, forget and learn more, there are some technologies, for example, if I take the example of the telecommunications sector, technologies such as the ATM, such as the frame relay technologies, these are really, or even the X25 technology for data. This is something that people learned, but you will not be able to get value or deliver value from these technologies today. For example, I know within our company, for example, when people who are specialized in X25 protocol, we took out X25 protocol from the value chain. So this is what I was referring to when I said forget and learn more. But for sure, you are completely right, and I do agree with this. When you learn when you get new knowledge, you need to reconsider what you know already and push forward the knowledge that you have. And this would be much more helpful than reinventing the wheel every time. It's not a question of reinventing the wheel, it's a question of reconsidering the wheel itself to make it to innovation, for example.
Okay, interesting. Thank you, Oliver.
So I'd like to switch gears just a little bit and now focus on the questions that are coming up on the Q&A panel. And I'll take one liberty with two questions that are similar. The first question says, will the demand for data analytics lessen in the future due to AI? And kind of the flip side of that question is, what is the shortest path to become a data scientist expert? What skills do you need? So with, do you think the demand for analytics will lessen in the future due to? Kyle's been silent. I'll start with Kyle on that.
Well, I mean, I don't have a crystal ball, but I don't think it will. I think we still will always have to understand what we're doing, and that's what analytics, the word analytics, means to me. In terms of just operationalizing analytics, maybe we'll have tools that don't require a whole lot of understanding that enable us to make business decisions and decent business decisions. But I would separate those two things. Maybe I'm not sure about the meaning of the question, because for me, analytics is much more than the operationalization of analytics. We'll always have to understand what we're doing, I think. That's never going to go away. We're going to have to train the people that make the calculators, right? So I guess I'm more of an academic in that sense. Having depth of knowledge and understanding is always going to be important, I think.
think those are the folks that are going to be driving innovation forward for the folks to operationalize those models. So when the models start breaking down, you need those folks who can bring out the hammer and the tools that can actually dig open this model and figure out where they're going and improve upon those models for the future. So those jobs may not be as much as maybe other jobs, but they are out there. It's learning what skills you want to learn and attain and build a future upon. So operationalizing machine learning models are probably more relevant for an industry setting, and you're going to find a lot more opportunities out there. But for example, if you're looking to work in a research lab or a national lab, you definitely want to understand what the implications of your model are and how it works.
And that's something that I kind of want to touch upon, the DevOps part of working with models. And the thing you talked about before, Kyle, was democratization of data science within a company, that more learn what is this magic box, like what happens when it breaks down and what can we do to actually address it.
Yeah.
Well,
and just for the audience, we've got kind of like the students in Kyle's class, we've got a wide range of experience and abilities. For the general questions on how do I become a data scientist expert or data analysis expert, in my own mind, I break them up, and this is partly because of my context in Databricks. There is the data scientist that focuses on the optimization of algorithms. There is the data engineer that focuses on getting a good, clean pipeline of data for the data scientist. And then there's the data analyst that looks at data science at scale as a way to solve and answer business questions. So there is no shortest path, there is no optimizing, there is no hack issue from point A to point B, the fastest way. But think about you as a person and what where your curiosity lies, where your strengths are, and figure out where you might want to fit in one of those three roles, or maybe all three of those roles. And each role has a specific set of characteristics and point of view that are important. So there is no shortest path, but just know that there are three things that we're talking about here. And then the fourth thing in my mind is when we talk about scale has to do with, and that's why I always smile when Lewis brings this up, it's about DevOps, because when you want to scale and use larger data sets than what one might find in Databricks Community Edition, there are costs associated with that scale. There are costs in terms of storage, in terms of cluster compute, in terms of the time it takes your admin on the back end to talk to somebody else to figure out why your costs are so high. Delivering a large-scale analytics course might cost you $25,000 a semester. Anyway, I just wanted to sort of put all of these things in one discussion, saying there is no shortcut, but think about the different roles and think about the trade-offs involved when you start looking at numbers in the billions or trillions in terms of records and analysis.
Thank you for the summary, Rob.
And if it's okay, there are, Olivier, there was a question for you from John Wook from Cal State LA. If you see it on the Q&A, are MBA students comfortable in learning cutting edge technology, and how much do you incorporate teaching the technology as part of your course or those courses?
Yeah, thank you. In fact, in our MBA program, and this is the reason why we introduced this program in the management field, we think that today it is difficult to manage technology without and full knowledge in, let's say, social science, in the management of science, in management itself. So you are dealing with systems, and these are very specific systems. When you are dealing with artificial intelligence systems, for example, these systems embed a technological component as well as a management component. So when in our MBA program, we teach our students concepts related to the governance of data, to the management of data, but we teach them at the same time processing as well as programming. So we are looking for a kind of balance between technology and management. And this is we spend time, in fact, defining the skills that belong to each and the syllabus that's going to serve, that is going to feed each of them. So all our program, the architecture of our program is built upon this balance between management and technology. And both of them are required in order to prepare for this role that we call the Chief Intelligence Officer. And this is one side of the question. Another side of the question, there is something that is really specific to artificial intelligence systems, is that it is not sufficient to run one cycle of machine learning, 2 cycles, 3 cycles. This needs to be done permanently. So the idea of DevOps, because we have been talking about DevOps in the previous question, is that you need to integrate or get in DevOps the techniques for maintenance, for the maintenance of artificial intelligence system, because an artificial intelligence system will be evolving and data will be evolving at the same time. So, and this is, by the way, Rob, with regard to the previous question, this is the reason why there will be a demand for data scientists, because we will be developing artificial intelligence systems, and we need to think about maintaining these artificial intelligence systems during the whole life cycle. So to come back to the question that I addressed, there is a balance between management and technology, and data is at the heart of all of this, because today we are not able to train artificial intelligence systems with small data sets. Artificial intelligence systems require huge amounts of data to get them to the accuracy level that we want them to be. I don't know if I answered the question, Rob, but I tried to provide some ideas.
Yeah, you know, an interesting research area is actually about designing algorithms that don't need huge amounts of data. And there is some progress in that area. And I think that's probably where the future is. I mean, if you think about the cost of some of the latest models, if you think about GPT-3, GPT-4, I mean, they cost millions of dollars, and you can't expect, it's not sustainable, right? So I think maybe if we look into the future, if we look at quantum computing, for example, maybe, you know, design algorithms for quantum computers that don't require that amount of data. So, yeah.
I just want to touch upon that and say quickly, I mean, you're absolutely right. There is actually the state-of-the-art research is in things like few-shot learning and one-shot learning, where folks can just learn from smaller amounts of data as opposed to building these large corpuses and have these 180 million or billion parameter models that barely be in the future a state-of-the-art quantum computing, maybe in 5 years, you know, 5 to 10 years we can get there. But just wanted to chime in there.
Yeah, absolutely.
And we've got a question from Georgiana, and I'll focus this initially to Kyle, but answerable by any of the panelists. And just as a heads up, we've got 6 minutes left before the overlords shut down the session summarily. And I hope that made you smile, Robert. For Kyle, are you following up with your students after they graduate? Do you learn from them new challenges and problems that come from outside of academia?
Yes, and I saw that question and I keep needing to answer it, and I keep doing other things. I do follow up with some students, not every single one, obviously. Some of my students have gone on to pursue PhDs. Some of them have started in some big name companies. I think in terms of like what they're actually working on and what the challenges are, I don't really get too much insight into that. Do you mean like specific problems that they're working on? Yeah. So no, I suppose, okay, so the answer is yes and no, right? I follow up, I keep in touch, we're all connected on LinkedIn, but I don't necessarily have insights into specific things that they're working on.
Okay, there was a question from Haji, and I think Olivier, maybe try mute. I don't know if somebody's mic is giving us a little feedback. Oh, I can't find it now. It's somewhere in the queue. Maybe it's too far up. I guess a general question for all of the panelists. What would make somebody successful in the field of analytics? And I'll make that general to data scientist, data engineer, or data analyst. So what, if you had to say you must do or be these three things, what would make somebody successful in this field?
Very curious to understand the domain.
Luck.
Luck, yeah.
Read the Black Swan.
I think Kyle, I think luck is something that the data analyst and data science should be looking for and not looking for. And to be successful in life, they should be engaged more than being involved, because when you are engaged, you are able to deliver value. You are able to deliver value to the work that you are doing, to the company with whom you are doing. So it's a question of engagement, getting them engaged, and to complete what Dennis mentioned. In fact, you need to know the business. This is very, to have some basic knowledge in mathematics, for example, in physics, computer science, in algorithm, because this is the basis of data science. It is difficult to perform data science without the knowledge in algorithms, in fact. But most of all, luck, looking for luck, in fact, and by being engaged in the process in which you are working and that you are developing.
Well, I would argue that you can't look for luck by definition, but
yeah. But I would add, and I think I would add, and it's kind of what you said, but responsibility, taking responsibility,
yeah,
really owning it. If you get analytics requests, you own it, and you make sure that happens. That will take you a long way, a very long way.
And owning it also means that.
Sorry. I was just saying, yes, it takes time to build expertise. So there are no shortcuts. There are no quick solutions. I think just like Linus and Olivier were saying, you have to have a foundation, a solid foundation. That's what we as teachers are here to provide. And everything else is up to the student, right?
Yeah, and fail fast. And fail a lot.
By being agile, yes, I'm looking at what you are doing.
So,
yeah, and you will fail.
so one last quick question. We've got about a minute or two left. This is from Haji. The advantage of teaching with Databricks and Spark is that it is simplifying the big data computing process. Let's compare it to the era when Microsoft simplified the use of a PC decades ago. By this simplification, are your students more interested in the computing part or the data science part? And somebody's going to get cut off in the next 60 seconds. So I'll turn it over to Linus, because he's got the grimace.
Oh, I do. I was...
Smile.
Okay, smile and wave. No, I think they are, from the students I've worked with, they're very fascinated by like that they can start suddenly work with big data. They're like, wow, like 1 million rows. Could I even manage that? Like they're comparing it to Excel mainly sometimes, or smaller data sets. And that's kind of something that something I noticed. Kyle, please let's see if you can.
beat the clock. So for my course, I've taken that component of the class kind of out of the learning objective of the course. And by providing Databricks and an environment where people can sort of more easily do the machine learning bit, I make it very clear upfront and set the expectations that this is not a data engineering course. This is a how to distribute machine learning algorithms in a MapReduce framework course, right? So just being very specific about the expectations, I think makes it easier for people to focus.
All right, so I'm going to wrap it up. Just to say that I apologize. I have a young child crying in the background, but our time is up. Within 5 to 10 days, there should be a recording online. Go to the same URL that you used to register and join the event. And thank you so much, Robert, for the production assistance in the background. Olivier, Linus, Kyle, and Srijit for joining in the discussion. It's been great. I learned a lot. Thank you so much.
It was a pleasure. Thank you very much.
Yeah,
Thank
it was a
you.
pleasure.
Thank you. See you.
Bye.
Bye.
All right, that's a wrap.